Slopes of lines. Our objectives are to find the slope of a line, as well as use slopes to identify parallel and perpendicular lines. Why learn this? You can use the graph of a line to describe your rate of change or speed when traveling. Let's look at the pieces that make up the slope of a line. The rise is the difference in the y values. The run is the difference in the x values. You can think of slope as rise over run, or the change in y over the change in x. So if you look at the example to the right, reading the graph from left to right, we're rising 6, so 1, 2, 3, 4, 5, 6, which would be our change in y, and our change in x would be 1, 2, 3, 4 to the right, so it's positive 4. Once you have your slope of 6/4, you can then reduce it to 3/2, because the slope of 3/2 is the same as the slope of 6/4. Think of it this way. You can rise 3, run 2, and then rise 3 and run 2 again. If you wanted, you can do it again. You can even do the same thing with 6/4. Rise 6, run 4, rise 6, run 4. However, let's look at a few examples. Use the slope formula to determine the slope of each line. So from A to B, we want to calculate our change in y over our change in x. So our change in y is our rise, so we're going up 2, and then we're running 1, 2, 3, 4, 5. So it is rise over run, or change in y over change in x. Let's look at CD. Well, we're rising 1, 2, 3, 4, 5, 6, 7, 8, and we're not going anywhere in terms of running. Notice how you have a 0 in the denominator. That doesn't work out so well. You can't have a fraction with a 0 in the denominator because it becomes what is classified as undefined. Let's look at a couple more examples. Let's look at EF. So we're not going up and down any, so we have 0, but we are going to the right 3. Well, we can reduce 0 over 3 to 0. You can have a 0 as a numerator, once again, not a denominator. So if 0 is a numerator, you have a slope of 0. Think of it as you're not rising or running, like you're not rising or shrinking any. Okay? So let's look at GH. So from left to right, we're going down this time. 1, 2, 3, 4. So we're going down 4, and then we're running 1, 2, 3, 4. So we're going down 4, which is where that negative comes from, and we're running 4. So our change in y and our change in x here. All right, well, we can reduce that to -1. Let's summarize this up. So a positive slope increases. You can think of it as increasing as time goes on. A negative slope decreases as time goes on. A 0 slope, think of it like a ski hill. If you have a 0 slope, you're not going up the slope or down the slope. You're just staying flat. And you're undefined. Well, you can't really ski down a cliff. You kind of just jump down a cliff. So it's undefined. You can't state anything else with it. There's no rise or run that would work with it. All right, let's go a little bit more specific now. So we have our parallel lines theorem. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. So if two lines have the same slope, they are parallel. The perpendicular lines theorem states that in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Well, to get the product of -1, you would multiply by the opposite reciprocal. So think of it like A over B, and the opposite of positive A over B would be negative, and then you need your reciprocal. So flip it, B over A. So opposite, if it was negative, it's now positive. If it was positive, it's now negative. that covers our opposite. And reciprocal, you're going to reciprocate the fraction, so you're going to flip it. So if it was a over b, it will now be b over a. So if your slopes are opposite reciprocals, your lines are perpendicular. Let's look at a few examples. We're going to determine whether lines are parallel, perpendicular, or neither. So we need to know what the slope of AB is and the slope of CD is. Alright, so we want to find our change in y. So let's see, we're going down 1, 2, 3, 4. And then we're going to the right 1. So our slope is -4. And from C to D, we're going down 1, 2, 3, 4. And we are going right 1, so +1. And that gives us -4. Since our slopes are the same, line AB is parallel to CD. You don't want to just look at a graph and go, oh, they look parallel, and state that they're parallel or perpendicular or neither. Because sometimes graphs look really similar, and what you're able to see that they show you or that you were able to graph might not show you all the data. So if you find your slopes and your slopes are actually the same, then you know for a fact that these lines are parallel. So let's look at this next example. For this one, we want to know what the slope of ST is, and we want to know what the slope of UV is. Alright, so for S to T, we're going down 1, 2, 3. So we've gone down 3, and we're going over 1, 2, 3, 4, 5, 6, 7. So we have a slope of -3 over 7. Alright, so for UV, we're going up 1, 2, 3, 4, 5, 6, 7, 8. And then we're going over 1, 2, 3, 4. And we can reduce 8/4 to simply 2. Alright, well, they're not parallel. You can clearly see they're intersecting. And they're not opposite reciprocals. They're opposite, like that's negative and this is positive, but they need to be both opposite and reciprocals. So this one would have had to have been 7 over 3. So therefore, this one is neither. Let's look at the third one. We want to find the slope of FG and the slope of HJ. Okay, so for FG, that would be the red one, the positive one here. We're going up 1 over 1. Well, that simplifies to 1. And now for HJ, we're going down 1 over 1. So we're going down 1 over 1. Well, they're in fact opposite, and they are reciprocals of each other, because no matter which way you look at 1 over 1, if you flip it, 1 over 1, it's still there. So they are in fact opposite reciprocals, and therefore they are perpendicular. So we know that FG is perpendicular to HJ. And that concludes our lesson on slopes of lines.